Good morning, students. Today we are going to start our engineering mechanics practicals. Okay, in our engineering mechanics lab, all together we are going to conduct the 7 experiments. Here, as per syllabus, only 6 are mandatory. Here, but that 6 we are going to complete. But one more additional experiment we are going to conduct. So at least 7 experiments we are going to conduct in our engineering mechanics lab. Okay. So the first experiment which we are going to learn is the verification of law of Polygon of forces. Verification of law of Polygon of forces. Now, before explaining this experiment, I would like to give you some basic information or basic knowledge about this law of Polygon of forces. Now, all of you know about the vectors, scalars and vectors. Okay, a vector is a physical quantity which is having the magnitude as well as direction. Okay, for example, the force. The example of the vector quantity is force. Force is a vector quantity. For the complete specification of the force, we require its magnitude as well as direction. The next point is how we can add the vectors. Okay, you have studied the addition and subtraction of vectors. Now the next one is how to add the vectors. Now for addition of the vectors there are 2 methods. The one is the graphical method and other one is the analytical method. In analytical method, we express the vector in terms of I, j, k, in terms of the unit vectors along x, in terms of the component along x, y and z direction, and we add that components. Okay, so that is the analytical method to add the vectors. The another method is the graphical method. You can use the graphical method to add the vector. Now, which are the graphical method to add the vector? The first one is the triangle law. You must have studied the triangle law of vector addition. The second one is the parallelogram law. And third one is polygon law. Okay, these are the 3 graphical methods with the help of which we can add the vectors. Okay, now in graphical methods, to add the vector, the first important thing is to express the force in graphically. How we can express the force graphically or any vector? It may be the acceleration vector, it may be the velocity vector. So how to express any vector graphically? So for example, suppose this is one force whose magnitude is 100 Newton, which is inclined at an angle of 30 degrees with horizontal. This is the direction, this is the magnitude. Now how to express this or how to represent this force graphically? To represent this force graphically, draw a line parallel to the line of action of this force. This line along which the force acts is known as its line of action. So to express or to represent this force graphically, draw the line parallel to the line of action of this force. Since we have drawn the line parallel to the line of action of the force, means this line is also inclined at about 30 degrees with horizontal. Okay, and then select suitable scale to represent the magnitude. Okay, so here I am representing the, I am selecting the scale. Suppose 1 centimeter is equal to suppose 20 Newton. If I select this scale to represent the magnitude, so to represent this 100 Newton force, I require the length of this line segment of 5 centimeter. Okay, 100 divided by 20, so 5 centimeter. So this 5 centimeter length AB represent a force of 100 Newton. Okay, so in short, to express the force in graphically, to represent the force graphically, you just draw the line parallel to the line of action of that force and select suitable scale to represent its magnitude. Here I have taken the example of force. Here in the similar way, you can represent velocity, acceleration, displacement in vector form. Okay. So this will be required for the graphical addition of the vectors in triangle law, parallelogram law and polygon law. Now what is the triangle law? Okay, for example, suppose the 2 forces are acting on a body. Here this is P P and this is Q, which makes angle of theta degree with horizontal. If I want to add these two force vectors, okay, so triangle law states that when two forces act on a body are represented by the two sides of a triangle taken in order, then the third side of that triangle represents their addition taken in opposite order. I am talking only about the addition. Okay, so if suppose I want to add these two vectors here, which is P and Q, so you have to represent this force P graphically. So this length represents the force P graphically with some suitable scale. Then draw the line parallel to the line of action of this force Q here, and with the same scale you have to represent this force Q also. This length represents this AB length represent the force P, and this BC length represent the force Q by using the same scale. Okay, so when these two forces act on a body are represented by the two sides of a triangle taken in order, then this closing side or the third side of the triangle represents their summation. So this AC vector represents the force P plus Q. Okay, this is the summation. Okay, in parallelogram law also it is the same. Here parallelogram law and triangle law are applicable only for the two vectors. Or when we want to add the two vectors, here we can do the triangle law and the parallelogram law. Whereas when we want to add the more than two vectors, here we have to add the law of polygon. Okay, now what is the parallelogram law? In parallelogram law, if these two forces are, or these two vectors are acting on this body, are represented graphically by the two adjacent sides of a polygon. Sorry, parallelogram. Yeah. Here we are represent these two forces as the two sides of a triangle taken in order. Here in parallelogram law we are representing them as the two adjacent sides of a parallelogram. If I complete this parallelogram, here in parallelogram the opposite sides are equal and parallel, then this diagonal which is passing through the intersection of these two vectors represent their summation. So this is P bar plus Q bar. Okay, if you measure this length of the diagonal, which gives you the summation of these two vectors. Here, this length gives you the magnitude, and if you measure this angle, this gives you the direction. Let denote it as alpha. Okay, so this is the triangle and parallelogram law, which is applicable to add the two vectors. It may be the force vector, it may be the velocity vector, or any other vectors. Okay, now the third one is the polygon law, which we have to study here. Okay, when more than two vectors are there, we have to use the polygon law. Yeah, and the polygon law is just extension to the triangle law. It is similar to the triangle law. Okay, here two forces are there, that's why we got the triangle. But when more than two vectors are there, and if you follow the same procedure, here that figure will be the polygon. It may be any polygon. Okay, it will be the quadrilateral, it will be the pentagon, depending on the number of vectors which you are adding. Okay. Now what is this polygon law? In polygon law, suppose there are a number of vectors. Suppose this is P, this is Q, and yet this is S. These are the three vectors. Here we know their magnitude as well as direction, and we have to add these three vectors graphically. Okay. So for that we have to use the polygon law. Now what polygon law states? Polygon law states that when number of vectors are there, okay, and to add them, you have to represent these forces graphically as a side of a polygon taken in order. Okay, so I am going to represent these forces as the sides of a polygon. Let this force, this line AB represent the force P with some suitable scale. You have to decide the scale. Here you have to decide the scale such that this figure, while deciding the scale, you have to just observe the force or vector of minimum magnitude and maximum magnitude, and according to that you have to decide the scale such that this figure should not be very small or very big. Okay, so represent these vectors as the sides of a polygon taken in order. So this AB line represents the force P. Now from this head end, you have to represent the next force here, which is Q. So draw the line parallel to the line of action of this force Q. This line, such as BC line, represents the force Q. If this angle is theta, this will also be theta because these two lines are parallel. Then from this head end, represent the third force here, third vector, which is S. So this CD line represents the vector S. Here I have drawn the line parallel to this. if suppose this angle is theta 1 with positive x axis, here, then this angle will be theta 1 with positive x axis. Okay, so when number of vectors are there, and if you want to add them, you have to represent them, these vectors graphically as the sides of a polygon taken in order. You will observe that all the vectors are in order. You can use any vector. After P, need not necessarily that you have to go for Q. You can go for S also. You can select any sequence. Yeah, but all these should be in order. Order means the next vector you have to start from the head end. Yeah, this vector you have to start from the head end. Okay. So if I represent these vectors as a side of a polygon, then this closing side of the polygon represents their summation. Okay. So this line AD represents the vector P bar plus Q bar plus S bar. This gives you the summation. Closing side represents the summation of that vector. Here in triangularity also it is similar, but in triangle only two forces are there. That's why this figure we got as a triangle. When more than two forces are there, this is the polygon, and it is known as the law of polygon. Here, basically, these are the laws which are used to add the vectors. Related to our subject of engineering mechanics, in which we are going to deal with the force systems. Okay, we are going to apply this law of polygon to the force systems, and that's why it is the law of polygon of forces. Okay, related to our subject, we are using it as a law of polygon of forces because we are applying this law of polygon to the force systems. Otherwise, you can apply it for the vector summation, for any vector summation. You can add acceleration vector, velocity vector, displacement vector, or any other vectors also. Okay, we are going to use it for the forces. Okay, so just remember what is the law of polygon of forces then. Here suppose on any body, number of forces are acting like it is F1, F2 and F3. Okay, and if I represent these three forces by the three sides of a polygon taken in order, then this closing side represents their summation. Understood? This is the basic concept of the law of polygon of forces. Here, now we have to verify the law of polygon of forces. Here, before proceeding for this verification of law of polygon of forces, this was the basic concept which you have studied up to in your 11th and 12th standard exam. Okay. Now, since in our subject we have to study the different type of force systems, here force and force system. Here I assume that you people know what is in the force and how can you define the force, what is the unit of the force, and other things related to the force. Okay. So I am not going in deep about the force. Here only I would like to tell you about the resultant. What is meant by resultant of a force system? What is meant by resultant? Okay. Now, what is the resultant? Consider this is one body on which suppose these two forces are acting. F1, F2 let and the name is theta. Okay. So, resultant of this force system defined as a single equivalent force. What is resultant? Resultant is a single equivalent force of the given force system which produce the same effect as this number of forces producing on the body. Okay. There are two forces F1 and F2. Whatever will be the effect produced by these two forces on the body, if the same effect if we created by using a single force here, then that single force is known as their resultant. Okay, in the combined effect of these two forces F1 and F2 on the body and the effect of this single force on the body, if this effect is same, we can say that this single force is the resultant of these two. Okay, so resultant is a single equivalent force which produces the same effect as the number of forces producing on the body. Okay, then which are the different methods to find out the resultant? Which are the different methods to find out the single equivalent force? Okay, now again to find out the resultant there are two methods. One is the analytical method, other one is the graphical method. Before explaining this analytical and graphical method to find out the resultant, let me tell you, I explain you the definition that it is a single equivalent force for these two. Now since it is a single equivalent force for these two, this resultant force is nothing but the vector summation of these forces. If I take the vector summation of these forces, I will get the resultant force. Okay, here resultant is a single equivalent force, but how we can find out? Here by adding the forces vectorially. Okay, force is a vector quantity, we can't take directly. Suppose this F1 is 20 Newton and F2 is 30 Newton, so resultant won't be equal to 50, 30 plus 20, because it is a vector quantity. We can't add them like a scalar. Okay, so we have to take the vector summation. Yeah, so to find out the resultant, we have to take the vector summation of the forces. And how we can take the vector summation? Again, there are two methods. One is the analytical method and another one is the graphical method. Again, in graphical method, same method we are going to use the triangle law. Here, second one is parallelogram law, and third one is the polygon law. Since all these three are the graphical methods to add the vectors, and we are going to use these three graphical methods to add the forces to get the resultant, we can say that related to our subject, we can say that these are the graphical methods to find out the resultant. Okay, triangle law, parallelogram law, and the polygon law are the graphical methods to find out the resultant. Okay, so this is all about the resultant. It is just a vector summation of all the forces. Now to find out the resultant in analytical method, listen to me. In analytical method, we are going to use the resolution method. We are going to resolve the forces and we are going to find out the resultant. And in graphical method, we are going to use the triangle law, parallelogram law, and the polygon law. Out of that, here we have to study the law of polygon of forces. We have to verify the law of polygon of forces. Okay, here by doing some experimentation, we have to verify that law. Okay, so to verify the law, basically every student should know what is the law of polygon of forces. Okay, now before coming to that law of polygon that already I explained, here, since we are verifying it by using the analytical method as well as graphical method, here, so what is this resolution method? Okay, I already told you that the resultant is a vector summation of these two. Let's consider these two forces. Yeah, it is a vector summation of these two forces here, but we cannot find out this resultant directly R equal to F1 and F2. We cannot take the scalar product. Scalar product summation. Okay, to find out the resultant, we have to take the vector summation. And in vector summation, we cannot add the magnitude directly. Okay, then what is the method? Either you have to express these forces in vector form and you have to add them. Here, express each force in terms of I, J, K and add them. Here, and this coefficient of I, coefficient of J, and coefficient of K are nothing but the component of that particular force along X, Y, and Z direction respectively. Okay. Then, instead of expressing them in the vector form in terms of I, J, K, in resolution, we are going to do the same thing but in a different way. Okay. What we are going to do? Here, we resolve each force into two rectangular components along X and Y axis. Here, suppose this force is F2 and suppose this angle is instead of this, if I consider this as a theta 1, here then resolve, it is actually in the second quadrant, so its X component will be towards left and Y component will be upward. If this angle is theta 1, then this component will be F2 cos theta 1 and this component will be F2 sin theta 1, provided this angle is theta 1. Okay, the component adjacent to the given angle is cos component. Okay, here we have to resolve this force into two components such that the combined effect of these two components should be equal to this original force F2. Okay, this F1 is along the x-axis itself, so its x component, that force itself, and y component will be 0. In this way, I have resolved this force system. Similarly, if I resolve this resultant, then its x component is Rx and y component is Ry. Okay, here. When we study this lesson here at a time, we are in details we will study about this resolution process. So I have resolved this resultant in two components. Now I already told that the resultant is an equivalent force for this F1 and F2. Here I cannot find out the magnitude of the resultant directly by adding the magnitude of the component. Here because they are acting in a different direction. Here, but I can calculate this Rx by taking the algebraic summation by adding this F1 and F component along x-axis directly by using the suitable sign convention. because they are also the vector quantity. These components are also the vector quantity, so we cannot add them directly with their magnitude. We have to consider their direction also. Yeah. But since this Rx in x direction, this f1 and this f2 cos theta 1 are also in x direction, so by taking some suitable sign convention, we can add them directly instead of expressing them in the vector form. Okay. So we can write this Rx equal to f1 and assume that force towards right positive. So this f1 is positive minus, why minus? Because it is acting towards left. So it is minus f2 cos theta 1. In this way I can calculate this Rx and Ry equal to, here this is the vertical component of the resultant, which is equal to the summation of the vertical component of these forces. Y component of this f1 is 0 and y component of this f2 is upward, that's why it is positive. Here we are considering that for adding the forces along x direction, we are using the component towards right positive. Adding the forces along y direction, we consider the upward force positive. So if I consider upward force positive or upward component positive, then the y component or vertical component of this f1 is 0 and vertical component of this f2 is upward, that's why it is plus f2 sine theta 1. In this way we can get Rx and Ry. Once you get this Rx and Ry, here we can use the triangle law to calculate this R, or by using the triangle law directly we can write down the mathematical expression, this R equal to under root of this Rx square plus Ry square. And this Rx is nothing but the summation of all x component. This is the summation of all x component. We can write it as the summation of fx. And this Ry is nothing but the summation of all y component, which can be denoted as the summation of fy. Sigma stands for the summation. This is the summation of all components acting along x direction. This is the summation of all forces acting along y direction. Here, so this resultant can be written as under root of summation of fx square plus summation of fy square. This is the magnitude of the resultant and direction of the resultant. Here this resultant makes an angle of alpha degree with horizontal. Here, so we can find out this alpha equal to tan inverse. It is Ry upon Rx. Or we can write down this alpha equal to tan inverse summation of fy upon summation of fx. In this way we can calculate the magnitude and direction of the resultant analytically. This is the analytical method, which is the resolution method. We have resolved the forces and we have taken the summation of all x component, which gives you the Rx or summation of fx. We have added all the y component, which gives you the summation of fy, which is equal to the Ry, and with the help of this fx and fy we have calculated the resultant by using the triangle law. This is the triangle law. Okay, if I represent this summation of fx along x axis, summation of fy along y axis, then this closing side represent their resultant. And here we can use the Pythagoras, so R equal to under root of summation of fx square plus summation of fy square. This is nothing but a triangle. Okay, so this is the resolution method, here then of which we can calculate the magnitude as well as direction of the resultant. Okay, now when we find the resultant of any particular force system, here I have already told you that this is a single equivalent force for the given force system, which produces the same effect. And single equivalent force is always the unbalanced force. Whenever any single force acts on a body, it is always the unbalanced force. Here, if I consider this body, if I resting on this surface, here it is in the complete state of rest under the action of two forces. Which are the two forces here? One is the weight, other one is the normal reaction. But if I apply one unbalanced force in the horizontal direction, because of which it starts moving in the direction of that unbalanced force with some acceleration. So remember, whenever any unbalanced force acts on a body, that unbalanced force is always responsible to produce certain motion. Okay, it is always the unbalanced force which produces the motion. Okay, then the next term which I would like to tell you is the equilibrium. You must have learned something about the equilibrium. Okay, now in short I am going to explain. Now what is equilibrium? When a balanced force system is acting on a body, we can say that it is in equilibrium. When a balanced force system acting on a body, we can say that it is in equilibrium. What I am saying, balanced force system. Equilibrium is nothing but a balanced force system. Okay, and when a balanced force system acts on a body, there are two different effects on the balanced force system. One is Because of the balanced force system, the body may remains in the state of rest, or it may remain in the state of uniform motion, uniform linear motion, not uniform angular motion. Okay, when a body is moving with a uniform linear motion, it means that during the motion, if its velocity is remain constant, uniform, we can say that it is moving under the action of balanced force system. If it is moving, if under the action of certain force system, if the body is moving with a uniform linear velocity, we can say that it is in equilibrium. Okay, so equilibrium doesn't mean that only state of rest. Even if the body is moving with a uniform linear velocity, we can say that it is in equilibrium. So equilibrium is nothing but a balanced force system. Now, when any body is moving with a uniform linear motion, is when velocity equal to constant, acceleration equal to 0. And according to the Newton's second law, here summation of F equal to ma. If a equal to 0, this term becomes 0, means the algebraic summation of all force vector is equal to 0. If algebraic summation of all force vector is equal to 0, it means that it is a balanced force system, or we can say that it is in equilibrium. Okay, so when a body is in equilibrium, it means that the force system is in the state of rest, or it is in the uniform linear motion. Okay. And when a balanced force system is there, or when any force system is in equilibrium, here there is no any unbalanced force. Here, and since there is no any unbalanced force, so for that particular force system, the resultant force is equal to 0. Okay, so for any particular force system, if the resultant force is 0, for concurrent force system I am talking. Okay, when a resultant force is equal to 0, we can say that it is in equilibrium. I am talking only about the concurrent force system. Okay, here for the complete equilibrium, there should not be any translational motion, there should not be any rotational motion. Here for rotational motion, the torque or the moment is responsible. Okay, here, so it is not always true कि अगर unbalanced force 0 है, it doesn't mean that always it is in equilibrium. Here, if the unbalanced force is 0, there may be an unbalanced moment of torque present in the system, and that unbalanced moment of the torque may produce the rotational motion. Okay, so just we are talking about the concurrent force system. So remember about the concurrent force system, it is in equilibrium. Here, its resultant force is 0, or we can say that vice versa. When the resultant is 0, the force system is in equilibrium, or if it is in equilibrium, the resultant force is equal to 0. Okay, yeah, so this is all about the basic things which are required for the law of polygonal forces. Yeah, now in law of polygonal forces, we are going to, here we have to verify the law of polygonal forces. Okay, in law of polygonal forces, what we are doing in our laboratory, we are creating one concurrent force system. Concurrent force system. Concurrent force system means when the line of action of all forces are acting at one point, then it is known as a concurrent force system. So in our laboratory, they are going to produce such type of force system, which consists of 5 forces. Okay, such type of force system we are going to create. Yeah, and for this force system, we are adjusting the magnitude of all these 5 forces and their angles here or in their direction, such that this force system should be in the complete equilibrium. The force system should be in complete equilibrium. Here we are going to arrange these forces and their angle, their magnitude and angle such that here the force system should be in the state of rest. Means it is in equilibrium. And if it is in equilibrium, just I told that if it is in equilibrium, it is the state of rest. And if I ask you for this concurrent force system which is in the state of rest, what will be the resultant? So resultant has to be equal to 0. Okay. Now, if this is a concurrent force system which is in equilibrium, yeah. Now with this concurrent force system, if I draw the polygon, yeah, so I am representing all the 5 forces. Here to draw the line to represent these 5 forces graphically, draw the line parallel to the line of action of the first force, then draw the line parallel to the line of action of the second force, then draw the line parallel to the line of action of the third force, draw the line parallel to the line of action of the fourth force, and draw the line parallel to the line of action of the fifth force. Okay. Now, if suppose this, if when you represent this fourth force and if the fourth force in at this point, suppose this is A, B, C, D, E, and suppose this is A dash. If the fourth force in at this A dash here, then this closing side of the polygon represent the resultant of these 5 forces taken in opposite order, because resultant is nothing but a vector summation of all the forces. Okay, so this closing side represent their resultant. Okay, and I told you that if the resultant is present, means the force system is unbalanced force system. Here, if the resultant present है तो it can't remain in equilibrium. It will be in the motion. Okay, but this force system is in equilibrium. We have arranged it like that. It should be in equilibrium. And if it is in equilibrium, here then this resultant has to be equal to 0. And to get this resultant 0, this last point must coincide with the first one. Okay, it means that for the system to be in equilibrium, here the force polygon must be a closed figure. You can say that this is a graphical condition of equilibrium. There are some analytical conditions also. Okay, so what is the graphical condition of equilibrium? If a certain force system is in equilibrium, and with that force system, if you draw the force polygon, it must be a closed figure. This last point must coincide with the first point. Here, if the resultant is 0, then only we can say that it is in equilibrium. Otherwise, it won't be in equilibrium. Okay, so what we are going to do in our laboratory, we are creating this force system which is in equilibrium. To keep it in equilibrium, we are changing the magnitude as well as angles or direction of the forces here, so that it should be in equilibrium. And with that force system, we are going to plot the polygon. Okay, and we have to plot the polygon, and we have to prove that in this polygon, if you plot this polygon, the last point will coincide with the first point. If the last point coincides with the first point, we can say that here the resultant is equal to 0. Okay, and hence it is a proof of law of polygon of forces. Okay, because system is in equilibrium, that's why resultant is 0, and since resultant is 0, here the polygon will be a closed polygon. Okay, this is the proof of the law of verification of law of polygon of forces. Okay. Now after the experimentation, here we have to do the calculation, and in calculation, here we are going to resolve each force into rectangular component. That calculation I will explain you later in the next video. Okay, but we have to resolve each force, and we have to find out the Rx and Ry by using summation of Fx and summation of Fy. And with that of this, you have to find out the resultant. Here, this resultant must be equal to 0. Means graphically as well as analytically, the resultant must be equal to 0. Here, aim of the experiment to verify the law of polygon of forces, and also give here only the law of polygon of forces verified. Okay. Now in next video, I will show you the actual experimentation. Here, actual how to take the reading, how we are going to create the force system. And how to prove. Then in the next video, I will explain you how to do the calculation. Okay, remember one thing, this is supposed to be the most lengthy experiment in your engineering mechanics lab. Okay, all together you have to take the 5 readings, you have to draw such type of 5 polygons here. So calculation is also a lengthy part, and performance is also a lengthy part. All other experiments are not that much time consuming. Easily you can do that in 1 hours, but this is little bit time consuming. Okay, thank you.